Welcome back, everyone. Every time I go, it seems like the window sizes change and stuff from screen to screen to room. So it'd be nice if I could just get one room than getting all this set up. So what we'll try to tonight, we are still in lesson 2. Is that correct? Is that what you're good? So we will maybe do a little bit of review. We'll go over a few problems. We can go into Math AS, the online homework problems. I heard some talk about yellow boxes and inputting certain things. So we can talk about how that is because there's some things.
There's some things I don't think we went over either.
Okay.
Coefficients and stuff like that.
Very good. Okay, so we'll talk a little vocabulary now, and we'll go back. You'll see we sort of talked about it, or we worked with them without saying what they were. So then we'll bring back the vocabulary, and we'll just go ahead and get started. I'm going also see if I can do this. I'm going to pull up YouTube, my YouTube channel. I found out there's a place when I'm live streaming that those who are watching the live stream can actually make comments. So I'll see if I can, but I don't always pay attention. So hopefully, if you're watching the live stream, you ask questions, just be patient with me. I might miss it from time to time, but I'll hopefully see comments. And uh, so my wife was watching. She was the one that found out that that other night when the volume went out, it was like making buzzing sounds on the other end, and it was really annoying. And so when I restarted and got it going, otherwise it would have been a whole hour of just, bzzz, you know. So we'll see how this works. I'm gonna get into YouTube. Yeah.
I tried to, I don't know if it was just me, but I couldn't, did you post the word of the day for Monday?
It was hard to me. I found it, but I didn't see
I
it.
did, but another student sent it to me. I was late in getting it done, so I'll put that first. And then when I got it, I hadn't had I put it in a module. The module itself was not published, which I probably clicked on a button and unpublished it. So now it should all be available.
So I checked it this morning at like 5 in the morning.
Yeah, I think it was more in the afternoon. So it should be there. If you do find problems, just go ahead and do it. It's again, there's no due dates and such, but if you can, when you find things like that, that'll help us make sure it's available for everybody. And it's just kind of a nice way to make sure everything is going properly. Let's see, let me go here, go to the channel. Shows that we are live. There's kind of a delay, so it's really weird watching it because I see what I did like 2 minutes ago. So there's a live delay. There's supposed to be comment area. Where's the comments? This thing keeps, so I'll just use, but I find when this thing goes out, then the webcam microphone picks it up. There we go. Okay, so there's that. We're kind of watching the live. And then there's a comment section here. Let's see. There we go. And it just says say something. So I guess I'm going to say one person's watching. So we got that. We'll just say welcome. And maybe they'll comment back or not. Okay. So what we're going to start with.
Your little green voice things that go on there. When you talk, normally you're a little.
Thank you. Okay, so that's what we need. So because my Bluetooth went out, I'll check to make sure. You're right. That's supposed to, so input, Logitech webcam. Hello, testing. 1, 2, 3. Move this. 1, 2, 3. That's making some noise. Okay. Internal speakers built in. We're okay there. And
Maybe it's different with webcam.
testing 1. Yeah,
What's your channel name so I can check?
Open Global Village. All one word. Yeah, so Should be working. Okay. Hello. So it's showing up in the showing up over here. I think it. Maybe I changed the setting on this little guy. It's on. Okay. Can you hear it? Yeah. It's all okay. Good. So we got sound. Now let's get some business done. Okay. So where shall we start?
You want word of the day so it's done?
Oh, thank you. I keep forgetting that part of it. So let's do it in yellow. Okay, good. So word of the day. Who's got something? Who's got a good word for us? Could be funny. Should we go funny? We've always tried to make it positive. We could do something funny. I don't know. Tacos. That might be the food thing. I think this afternoon. Tacos. There we go. Tacos. The lunch, the one just after lunch, he was hungry, so he said he made the word of the day hunger. So now we can feed the hunger with the tacos. Okay, good. So that's our word of the day. Great. So then let's go ahead and pop in here. We'll pull up, switch back to this. We'll go into Math AS, and then we can pull up, I'm seeing maybe the practice problems. They have a thing on the coefficient, some of the terms that we didn't address directly. For Unit 2, I think it was in here, but if we go down to the student workbook, and then let me resize this, it's just like go. Just turn that video off. Okay. I'm going to go down to the practice problems, I think, is where, because we kind of went over the media lessons. Is that what you remember? Okay, so practice problems right here. So let's talk about this thing. What is a coefficient? I tell you, that's the coefficient for the first one. What's the way you could describe a coefficient?
Number?
The number. That's good. The number in front. And I remember this from 7th grade. Algebra class, we had a substitute come in because my teacher never called them coefficients. We just called them the number in front. We had a substitute come in and called it coefficient. We thought we were in, we didn't know what a coefficient was, and kept on using these big words on us. And teacher just said, well, that's the number in front, and that's usually what math people talk about. So we picked up on it. So for the second place here, what's the coefficient going to be? Negative 3. Good. So the negatives will attach to the coefficients. This one here with the negative y. Good. So the invisible 1's there. There's always a number in front of the variable, and when I don't see it, it's a 1 or a negative 1. And so for the x, 1. Good. How about this one?
3/5.
3/5. The fraction is the coefficient. And there's a couple tricky ones in here. How about this one here? Does this have a coefficient? It's not 1?
1.
It's pi. Pi is actually a number. So in this case, yeah. Again, you can write it as pi, and the reason they write pi and it is a number is because it's more than 3.14. It's got some more digits to make it, you know. But yes, we could also think of it as 3.14, depending upon how much accuracy we need. Good.
And that's what that symbol means?
Exactly. That's exactly what that symbol means.
So the symbol itself means pi?
Yes. And it's the value, it means the value of pi. So it's a number, 3.14, 18. That's about as far as I go. You could put both, yeah. And for this, we won't test you like this. These questions are more just to get you used to looking at, we call these polynomials. How about if I do this, this one, 4x over 7. 4/7, exactly. So because I could also write this as 4/7 x, right? So the coefficient is really the whole number, the number in front, which is 4/7. Okay, the number part. And this is a little tricky part here. What do you say about this one, the last one?
1/5?
Very good, exactly, because we can write this as 1/5 times m. So the coefficient is 1/5. And I'm going to go ahead and write that up here. Another way of writing this is 1/5 m, because you'll see both of them, and they both mean exactly the same thing, but they look different, don't they? And they have sort of a different approach. This is m divided by 5 is how we would think of it, and this is 1/5 times m, but they both give us the same result. And again, this one here we could write as 4/7 times x. So getting used to working with fractions. And sometimes you write it like that, so forth. Okay. So coefficient, nothing scary, it's just the number in front. Okay. So when we have an algebraic expression, the other thing we do is we talk about terms. And what's a term?
Pieces.
The pieces, and they're separated by either subtraction or addition. So that's how we count terms. Okay. So this would have how many terms?
5.
5 terms, 5 things separated by addition, subtraction. What would you think a constant term would be?
Whatever doesn't have a variable.
Very good. It doesn't vary. It doesn't have a variable. So what of these does not vary?
1 minus 1?
-1.
Negative 1.
Negative.
And again, you could think we're subtracting a positive one, but again, in algebra, it's good to attach the negatives to the numbers. So -1. What's the coefficient of the first term? So
5.
usually, yeah, so we talk about the first term being the one furthest to the left, so the 5 would be it. Coefficient of the second term,
-1.
very good. And the coefficient of the third term,
Plus 1.
a positive 1, or we just write
No,
1.
positive 1.
I got down to the bottom of the screen here, but the word factors, what is a factor?
It's minus -1.
Well, they're going to talk about the fourth term. What does a factor mean? What operation are we doing when we talk about factors?
Multiply.
Very good. So it's things that are multiplied. So if we come to the fourth term, that's this one. What's being multiplied?
And
8.
1/8 times n.
N times 1 over 8. Okay. So it's asking the question slightly in different ways. It's really asking what's the coefficient and what are they multiplied by. So when I ask for factors, it's what are all the things that are in there being multiplied. So 1/8 and n. If I ask for the coefficient, you just tell me 1/8. If I ask you for the variable, you just give me n. When I ask for the factors, you give me both. Does that make sense? So factors, but the thing is, when you're thinking factors, you're always thinking multiplication. Okay. When you're thinking terms, addition or subtraction. Okay. So just, and this is mostly, don't worry too much, it's not like test type questions. It's just that when we start talking about things, we know what we're talking about. Okay. And I try to get better at it, but sometimes I used to intermix the words terms and factors and just kind of, you know, they're the pieces, but terms are the pieces separated by addition, subtraction. Factors are pieces, but they're connected by multiplication.
So the factor would be 1/8. That's the, it says list the factors in the fourth term, you just put 1/8.
Well, 1/8 and n, because they're both factors. The variable actually is a factor as well, because it's being multiplied. So the factors, yeah, so down here, we'll put 1/8, and I'll just put a comma so that I'm listing it, and n. So there's two factors. Two factors. Thank you for clarifying. Okay, so we'll go ahead and take our first picture of the screen so that when we move on, oops, I'll do double pages one. And by the way, over here, you'll see 1 of 1. It keeps track of how many pages. I can always go back, back and forth between the pages. Oh, I didn't know I could do that. That's kind of cool. Still finding out new stuff it'll do. Okay. So again, another one that just kind of walks you through some examples, answering some questions. The main part we want to be able to do is be able to take that vocabulary and be able to work with things like this, these polynomials. And that's what we were doing yesterday, right?
Monday.
Or Monday. Yeah, we weren't here yesterday, but Monday. And we were working with like terms, and we were adding things together. We didn't use the word coefficients. We didn't use, I sort of talked about terms a little bit, but I didn't define what they were. And that's what I find sometimes if we just start working with them and using them after we've used them, then it makes more sense. Does anyone want to look at any of these problems listed here? Should be fairly similar to what we looked at. Are we okay? Or?
Could you do D under 5? I know, I
Under
hate
5.
fractions.
It's okay. The good part is they throw a few fractions in here to get us to work with. But if you struggle with fractions, don't worry so much. We'll be okay without them. Most of the tests are going to cover concepts rather than can you do fractions or not.
Okay, then
But
I won't worry about it, but
yeah, on this one, it's going to be multiplying, so we'll multiply through. It's really not that bad, because when you multiply fractions, how do you multiply fractions? Straight across, tops and bottoms. So let's go ahead and do this one and show you it's not so bad, because we don't actually have to add fractions. It's when we have to add fractions because then we got to get a common denominator, and those are the ones where I find it can become very tedious. But what I want to do is also show you it's not so bad. I don't know what that circle does, so come back here. So what are we doing? Distributive property, right? So we did this before. We just take the number in front and multiply it by the first term and multiply it by the second term, right? So we're going to take 3/4, which is the fraction, it's a number, and we're going to multiply it by 2/5 x, and then the next thing we do is we take this plus from the middle, that goes there, and we're going to take 3/4 times 7/12. I'm going to do a little bit of a shortcut, but this will help with fractions that sometimes, yes, we can multiply straight across, but there is something else we can do with fractions that's kind of cool. because usually they want to reduce, and sometimes Math AS asks you questions with fractions, and they want it as a fraction, because some of the professors, they want you to work really well with fractions. I say, let's just get past it first, let's get the concepts and then come back to it, but both ways work. So we could take 3 times 2 and then 4 times 5 and then try to reduce it, but do you see some numbers that are between the top and the bottom that maybe could divide into each other?
2 and 4.
2 and 4. 2 goes into 4. So if we sort of cross cancel as we go, because when we're multiplying, it's all going to become one big fraction, and we're just multiplying the top and the bottom. So we could say 2 divides into 4 2 times. So see how we've reduced that. When we cancel out the 2, what's left behind? 1. Good. So now we're just taking 3 times 1. What's 3 times 1?
3.
So in the top we've got a 3. In the bottom we take 2 times 5.
10.
And we've got a reduced fraction. Okay. So you're going to see that this is it's a method. I know some students just want to go, well, let's just take 3 times 2 and then 4 times 5. We could do this, and that gives us 6 over 20, right? That seems easier, but then this can reduce, and you have to, and basically 2 goes into both of these. 2 goes into 6 3 times, 2 goes into 20 10 times. Notice we kind of got there a little faster. What I find is if you look at the smaller pieces, it's usually easier to work with. You work with bigger numbers, bigger problems, right? So if you work with them while they're still in pieces, it'll work out. Again, it is a little bit unfamiliar, but let's just kind of give it a try. And then there's still this x here, right? So this is, the first part becomes 3/10 x. That's all we did. We multiplied. So this is a little good stuff. We come to the last 2. We're going to multiply them. So I'll just, it's making one fraction. 3 times 7 and 4 times 12. And yes, you could just write 21 over 48. But do you see some factors that are common between the top and the bottom? It's the 3 and the 12. 4 and 7, no. But the 3 and the 12, so the 3 goes into itself 1 time. 3 goes into 12 4 times. So now to get the complete answer, it's just 1 times 7, right? Which is 7. And then in the bottom, 4 times 4. 16. Okay, so that's actually a good one to do. We can see when we're multiplying, if we build this way, if we get a strategy for working with them, it can help our confidence. And then if we're confident with fractions, I'll tell you what, you'll probably be confident with just about anything else. I'm still not completely confident with fractions. I don't like them, but they're there, so we deal with them. I'd rather just use decimals, but the rest of the world hasn't listened to me yet. I said, get rid of those fractions, just do decimals. Some of the world's listening. The metric countries, they don't need fractions. If you use the metric system, all you need is decimals. But in the U.S., we still measure with fractions, right? 5/12 of an inch. So we deal with it. Okay. Is that okay?
Yeah.
So far, so good?
Yeah.
And again, if it does cause stress, don't worry too much. We can work around fractions as easily as we can work with them. Guarantee that. Okay. Let's take a picture of that. And I don't know if anyone had a chance, but I'm also, with the last video, what I did is we broke it into 2 pieces because of the sound problem. So you'll have the videos will be first, and then if you look below the videos, you'll start seeing these screenshots. So they'll act as notes. So you get both. So you could just watch the video and you'll see these screens in there, and you could take screenshots yourself, I guess. But I think it'll help if I put sort of major times where we've got a screenshot, and then so some of you may just kind of scroll through and maybe you just want to check your notes. Maybe you wrote down something different than I did, or caught an error or something. Okay. So far, so good. So before we go too much further, does anyone have any specific questions that you run into in either the homework, online homework, in these practice problems that maybe, because see, I can tell the screen, I'm gonna scroll, but there's not that much more down in here. And I'm happy to look at any of these questions. Maybe we'll do this because this is one I know these will cause a few problems.
F and number 6.
Number 6F, okay, let's back up there. Okay, good. So we'll go to 6. And actually, let me bring it up here. So this is 6F. I also want to do 7B because it's a clear one. And then if you want, we can do D. There we go. Oops. Try to make the screen a little bit bigger. There we go. So this one is 6F. So what do we do with 6F? Okay, distribute. First thing is this -2, right? So we're going to distribute this. So we're multiplying by -2 3 times, 1 to each of the terms. It's kind of like take the parentheses off and share that -2 with everything. Is there another place we're going to need to distribute?
Yeah.
Where? So this negative is like a -1. So we're going to have to distribute to the back end here as well. So -1 times x squared, -1 times -6. Okay, good. So we got a -2 times 4x squared. Does that look about right? 2 times 4 is 8. Negative times a positive is negative. Then we got -2 times 3x. Negative times a positive is negative. 2 times 3 is 6. And the x just tags along because that's what it does. Okay. We're multiplying by x. And then -2 times -2. And I know it's my other class, it's really a -2.
It's positive? No.
It's positive, exactly.
Positive.
Negative times a negative. So it's going to be a +2, plus 4. 2 times 2 is 4. So right, the two negatives make it positive. 2 times 2 is 4. So that took care of the distribution to the first one. And then now we're going to distribute this -1. And as it goes through, really it's just going to change all the signs because multiplying by 1 doesn't do anything, doesn't change anything. But the negative will change all the signs. So it's going to be -x squared. And then a negative times a negative, that's going to become a +6. So notice how the second polynomial, the second expression, didn't change much except for all the signs changed. Now what do we do? Like terms, good. So where are the like terms?
Is it 8x squared and, or the -8x squared and
X squared, good. And so what's that give us? Oh, the 4 and the 6 as well, good. Those are like terms, and I kind of give different symbols. Okay, a -8 and a -1. So we're going to get a -9. They're both negative. We add them, and we take their sign. And the variable part does not change. There's nothing to add or do anything with the -6x, right? So it just comes down. Just comes along. No like terms. And then we got a +4 and a +6, +10. So we can combine those, combining like terms.
In this case, the first one is -9. Doesn't change the...
No, because we were doing it we were combining by addition, really. We weren't multiplying. So that's the place where it switches over. I know some of you think two negatives make a positive, but that's not correct. It only works with multiplication and division. Two negatives and multiplication, yes, that's positive. But when we're adding, where two negatives just become more negative. And I always make it personal. If I borrow $8 from you today and I borrow $1 from you tomorrow, does that mean that now you owe me $8? No, I still owe you. I owe you $9, right? I become more in debt. So it doesn't switch it. Only when we multiply.
And then in this, we're not trying to solve it, we're just trying to bring it down.
Very good. We're just working with expressions. When we get into lesson 3, which will be next week, next Monday, that's when we're going to start solving, and we'll actually get it equal to a value. We'll find out what the variable is. What is x as far as a value? But for this time, we're just getting more expressions, hopefully simplified expressions, but even sometimes simplified is more complicated, which is weird, but we're just rewriting the expressions. Okay, so far so good? Okay, so then what I want to do though is what's really happening with this 7b? What do we actually do with this 6?
Divide.
We are dividing, and we divide each one. So it really is a distributive property. We think of distributive property only as applying to multiplication, but it applies to division as well, because division is really multiplication, but the reciprocal of multiplication. So what we're going to do on ones like this is we're distributing the 6 to each of these terms, so we get 21m divided by 6. And then we take that sign in the middle, and that goes between the two, and then we're going to take 18 divided by 6. So this is these fraction ones, and it's kind of unnatural. Actually, I was doing this today with my 121 class, and none of them remembered doing it in 190, but it's kind of unnatural because usually we're used to adding fractions together, so we get a common denominator and make them one fraction. We don't spend much time splitting fractions apart. However, when you get to your calculus class, if you get there, which again, a lot of you maybe are not going to take calculus, but if you were, this is a technique that helps out by breaking things down, and so we teach it. I mean, we can go both ways. Okay, we're not quite done though yet. What do we need to do? Can we reduce 21 over 6?
Yeah.
Because what goes into both of them? 3. 3 goes into 21 how many times? And 3 goes into 6?
2.
Twice. So that's going to reduce down to 7/2 m. And notice how I put the 7/2 and the m separately. You could do 7m over 2 if you like. That would be exactly the same thing. Okay. How about the second term? What goes in? 6 goes into both. 2 goes into both, but also 6 itself goes in. 6 goes into 6/1, and 6 goes into 18 3 times. So we could write that as 3 over 1, or you could write it as just 3. Okay. Makes sense? So far, so good. Yeah, that's sort of in simplified form. And then C and D are just kind of obnoxious versions of the same thing with more to do, but I'd be happy to do either one.
So what do you do on C? Do you distribute multiplication first and then
Yes.
distribute the division?
So that's when you're working with the fraction, look at it's sort of like there's this parentheses around the top and the bottom. So we always work the top, simplify the top as much as we can, and then distribute. So yes, for this one, we're going to distribute the 3 first to both of these. And so then 3 times 4 is
12.
12a. And then 3 times 8,
24.
24, so negative 24. So that takes off the parentheses, which is part of what we do in math. We got to get the parentheses off so then we can work with everything. We didn't do anything with this plus 2, did we? So we just write it down. And we didn't do anything with the 2 in the bottom yet, so we write that down. Now you could at this time break this into 3 fractions, but are there some like terms up here in the top? Yes, there's a negative 24 and a 2. You'll find that if you clean that up first, it makes the next step a little bit easier. What's negative 24 plus 2?
Negative 22.
They're opposite signs.
Negative 22.
We're subtracting them. 24 minus 2 is 22. Is it going to be negative or positive? Negative, because it's more negative, right? Okay, good. So be careful. The signs are opposite, so we actually subtract. So we don't take 24 plus 2 and make it 26. We subtract them first, which is 22, and it'll take the sign of the number that's in larger magnitude. So all we did is we took the 12a, we left it alone, and then we combined these two here. And those combine into negative 22 all over 2. Good. And then what do we do?
We have to divide into each one.
Divide into each one. So this is another type of distribution. So just
6a.
good. So, and you'll start to get where you just do it in your head, right? I'm going to go a little bit slower just because I want you to see
Over 11.
each step. Exactly. So you could have done this. 12 divided by 2 is 6. So yes, 6a. And the denominator's gone. And then 22 divided by 2, yes, is 11. So notice how that whole thing simplified down to something without even a fraction. Okay, but you can't come up at the beginning of what some people would want to do is take the 2 into the 2 and just, cancel. It's got to distribute. It's got to distribute.
So for D, is it the last thing you're gonna do is divide by 6? Or are you gonna do that before you would combine the like terms of 3x plus 1?
Exactly. So we'll work with the top. We'll simplify that.
Yeah.
Probably add some like terms. And just like we did over here, we will divide everything by 6. And then we'll
put 3x
and
plus
3x plus 1.
Okay.
And you'll see what it does. Everything divides into this, so you end up with something without fractions, I believe.
So we still distribute like 3 to the 10 and the...
Yes. So again, it's a first step here, first step here. So we're going to go with 30x minus 12. Didn't do anything to the 6, so that's still there. But it's always good to kind of talk your way or think your way through a problem. What would I do this and what would I do next before you start doing it? Because if you can see it that way, then when you come back to it, it's a lot easier, especially as you're writing things down. And again, sometimes I'll have people, they'll just work with this part and then they'll come back to it, but then they forget how it all looks together. So we try to get you to just keep bringing things down that we didn't do anything to. So what would be the next thing that we can combine?
Divide. Oh,
Just 6 and 12.
6 and the 12 are like terms. So we have a negative 6 and a negative 12 and a positive 6, opposite signs. Subtract them. 12 minus 6 is 6, and it'll be negative. Good. So we get 30x minus 6 over 6. And again, it gets a little redundant, but that's a lot of math. It's just giving yourself the room to keep writing down things that we didn't do anything to. Don't forget them, because they're part of the problem, right? They're part of the question. And then now, what's the thing we want to do?
divide.
We want to divide everything, or the 2 terms, by 6. So let's switch colors. And maybe because we're running out of room, let's do that. Can we do 30 divided by 6 in our head? Isn't that 5?
So 5x.
So that's going to give us a 5x.
And would that be a minus 1? Or you cancel it
Yes,
out?
6 divided by 6 going to give us a minus 1. Is that good? Okay. And then we still have our plus 3x plus 1. And now it seems natural we combine these terms because there's no fractions parts. So I've got a plus 5, or I've got a positive 5x and a plus 3x, so that becomes
8x.
8x, and a -1 and a +1, 0. Now you could put +0 or just not anything. So it's kind of interesting that whole statement up here simplifies simply to 8x. That's all it is. This equals 8x. And that's what we use algebra to, is to simplify processes. Now, in a factory, there could be multiple processes, but there might be an easier way to get it done. Yeah, your boss tells you, go there, get this, go there, get that. Go. Why don't you just send me this one place? I could get it all at one time. You know, have you ever had a boss like that? They really didn't think through the process. You know the process, and that's what algebra can do. Is it can get us to simplify the thing, so we're not having to run all over the place. We just take one step and we're done. Then you look real smart, because then you're. But don't rub it into your boss. I found that doesn't work very well with bosses. They don't like when their employees show them that they're smarter than they are. You can be smarter than your boss, just let your boss think that they're smarter than you until you get promoted beyond them, and then you can do what you like. But always let the boss think he's smart, or she. I've had both a he and a she for my bosses there, and both are the same. Let them think they're smarter than you are. It's the game. Okay, so shall we take a picture of that one? Let's see what page we're on. Page 3. So the PP3. So those are recorded, and again, there'll be a screenshot saved. So if you want to take a look at those, there'll also be the video, so you see how they've been developed. Always available back to you. And not too much more left for us, so let's get a clean page. And again, just to show you, I can always go back. So I'm not erasing anything. I can even go back more. Now the thing is, I probably have to go back to the page it's from, because it just remembers what I wrote. But I can go back and forth any way I want to go. So it's kind of cool. I like this program, and it's only $20. I'm actually going to pay for it. Because they give you the free trials and you try them, and most programs after the free trial, they're not that great. I'll move on to something else, but this one, it's well worth the $20. So.
Are one of those ones gonna be in the test?
What's that? Probably. I may make up new tests. Usually, what I do, sometimes I put them in as extra credit, but this one, D itself, I've used several times in a test. And I'll tell you it's on the test, so just practice it. And you'll practice it a few times. You get it down. The thing is, it's got everything in there. Once you get it down, you can do just about all of them, because it's like the most complicated one. So I would look at D if it's, yeah. And maybe that's the one we'll put on the test. So I'll give you some choices too. As we get closer, you'll have a practice test, and I'll ask you guys want some extra credit in there. And those who come to class or watch the live stream. Oh, I forgot about our live stream people. See, I ignored them. Let's see. Doesn't look like they're asked. Oh, there's three people watching now, so we picked up 2 more participants. So if you want to chime in, send us a comment. We'll try to answer it. Okay, so it's kind of fun, right? Okay. So we talked about these ones at the end, the applications. Again, they're not as critical. Some of them are to help you make connections to other things, and this is to kind of get you connected between geometry. I think we worked a few of these. Does anyone want to take a look at any of these, or are we okay with these? I don't put these on the test, but that doesn't mean we shouldn't look at them, but usually means we don't want to. But.
You want to do 9?
9? Okay, 9's a good one, because if you can pick up 9, and it's actually not all that hard. Okay, so we want the perimeter. So I better change from blue because everything else is blue. Let's go to green. So we want the perimeter. What does the perimeter mean? All the way around. So we're told that this little distance here is B, and that this distance here is A. The step up is B, this is A. So if we were to start here, start walking around here, and then we walk this way, how far have we gone?
1A and 1B.
We did 1A and 1B. I'll just kind of and then we go up another B, right? So you could just, I mean, you could do this all in order, or you could keep track of it. We did one, so how many B's are we going to do? 1, 2, 3, if you want to think of it that way. But you could also, you know, with the idea of perimeter, just follow this unit around. And we're going to go up by B. It's just adding everything together. There's another A. Does that mean we're done because there's no more letters?
Mhm.
There's still sides.
It's gonna repeat myself.
Good. So, okay, so then I come down here. How far down have I gone?
3 Bs.
1, 2, 3 B's. Good. So we see that. And then when I come, so we'll add that on. And then when I come along the bottom, what am I going to do?
3 A's.
1, 2, 3 A's. Good. So you use what was in the top, and so then we add 3 A's. Okay. So how many A's do we have? 1, 2, 3, plus 3 more, 6 A's. And we'll put them first because A comes before B. How many B's do we have?
6.
3 plus another 3, 6 B's. So the perimeter is 6A plus 6B. And we don't know what A and B are, but if you give that to me, we could figure it out, right? We know the exact perimeter. So this is, a lot of times I'll do drawings like this, and so you can scale it if you needed to make maybe a fenced-in area like this. Then you can change the values for A, B, and C and actually create it. You know exactly how much fencing you need to make it happen. Okay. And again, 10 is going to be a similar type deal. You're just counting, and they've got ones that are marked along the top, and then you just got to figure out how far is that. Well, that's 1x, 4x plus 2x, so that looks like 7x down here. How far is this? Well, it's 10x plus 8x plus 3x gives you the bottom part. Okay, so again, the idea is it gets you matched into something that's a visual, geometric. Okay, and sometimes algebra, it makes it a little more understandable what a variable is. So when I say this side is 8x, how long is it? $8x, that's it, yeah. It's sort of think of it as a number. X is still a variable, so I don't, again, it allows me to put in a different value for X. If I put 2 in for X, then it's going to be 16. If I put 3 in for X, then it's going to be 24. So these are the things that, you know, we can use to vary things.
So then basically you would put 7x plus 7x plus 21x plus 21x and then add them together?
Yeah, yeah. And it's just going to be how many x's. And again, that gives you the perimeter, which is how much is needed around the outside. And again, if we're fencing in something, that's how much fencing we would need. If it's a building, it's how much wall length we would need. Or maybe how much, what do they call this stuff at the bottom? Molding, you know. All right. So what else do we got going for tonight? So we've got whole hours left. But again, I always try to make sure we have, oh, I should have saved that. Well, we'll save it later. Got some word problems. And some of you were saying earlier on that you've been working the word problems, and actually the word problems seem to be easier for you than the non-word problems. And that's good. Some say, no, not the word problems. I don't do word problems. Would you like to take a look at one or two of these? Or
Well, that first one, oh, a 13,
13.
you'd move the decimal point 2 places, so you'd have 0.098B. Is that the answer?
Let's see. Got sales tax. Keeps moving on me. So what do we do with sales tax?
Make it into a decimal.
So if we're going to do math with it, yeah, so 9.8%, how do we turn that into a decimal?
0 point.
Divide by 100.
Good. Now some will just say move the decimal over 2. That's good. But the reason we do that is because on the percent, we're either multiplying or dividing by 100. And when we go from percent to decimal, we're always dividing by 100. If we go from decimal to percent, we multiply by 100. So it's just figuring out which way is which. So 9.8% is right, is going to be 0.098. And how do we figure out the total amount paid? Now they want the total amount paid for an item that costs D dollars. So if we buy something that costs D dollars, now this is one way I have done this in the past. I have a hard time thinking of D dollars. Even what is that? So let's just give it a price. What are we buying? We're buying an item.
$5.
$5. Make it up. So how would you calculate the total price for something that costs $5 if I have sales tax on it?
That's fine.
By what?
0.098.
0.098 times 5, because that's what we made up. What does that give us?
And what's the
Gives you
number?
total.
Sure.
0.49.
0.49. Is that all we have to pay?
No, that, you're supposed to
Yeah,
add
add
that to,
Okay,
Tax.
good. See, this is the way, because some of you would stop here if I had the D in there. You might think you're done. This is just the tax. And we know it's the tax because we could calculate it, and we got a number, would you tell me,
0.49.
0.49? We know that that's not the price. We know we also need to add $5 because we have to pay for the thing, plus we have to pay tax on it. Okay. Well, here's where we back off a little bit. They wanted an expression, right? Let's see, what do they want? So write an algebraic expression. We look for the question. So what is this 5 really? We made it up, but it's
D.
the D. So we come back, this is D. And I kind of backtrack. I can't, up here, this 5 was D. So I couldn't really calculate. So this is going to be 0.0998 D. Now, do I have a couple like terms here?
D.
D. What's the coefficient in front of the D? The first D.
1.
Good, 1. What's 1 plus 0.098?
0.098.
1.098.
That's my answer. Okay. And what you just found out is when you need to find out the total price, you don't have to necessarily find the sales tax and then add it, which are 2 separate processes. You could just multiply 1.098 times the item's cost, and you would have the total cost. So again, using algebra, we've simplified the process. Instead of having to do 2 calculations where we do a multiplication and then add, we did the adding part first. And when we did the adding part, what did we add? We added 1 plus some number. Isn't 1 like one of your favorite numbers to add? Because when you're adding 1, it's just like counting. That's my favorite number to add and to multiply by, for that matter. So that's when we're working with percentages. Oftentimes the algebra, we can do this. We add the 1, which is 100% of the price. We add it together, and then that makes our calculation actually easier.
Because I think that one is one of the ones that's on the test inside the
Okay.
thing.
Yeah, that's
I
what they're
remember that
looking
one.
for. Yeah. They're looking for the total price. So you're always going to see that 1, so you could just say, okay, that's going to be the sales tax. I'm going to pay the whole thing. So it's always going to be 1 plus 0.98 first. Put the right thing in there. So I'm going to do that, and then I'll multiply it by the price So however you want to do it, but that's, if they're looking for the total. Now, if they were just looking for the sales tax, then it's 0.098 times D. That's just the sales tax.
And then they said that you didn't have to put the brackets, you could just put 0.98 and then D right
Yes.
next to after it.
Yeah, when we have a variable, we can just write them together. We don't even have to put the multiply sign. It's implied by just being next to it. Exactly. What else was I doing? So anyway, that's a strategy. And so if you struggle with word problems, sometimes that's an issue. It's just go ahead and put a number. Make a number. And maybe some of you, I see, you'll say, okay, let's say D equals 5. And you remind yourself that's, maybe smiley face. You made it up. Okay. And then you figure out how the calculation is. But a lot of times, I'll do it myself. I can do the calculations thinking about $5. But if I'm thinking of D dollars, it's harder to think about.
Mm-hmm.
And maybe I can work through it, but I use up more brain cells and maybe more time and more frustration or whatever. So sometimes it just when I give you a number, it just flows. And we could have said $10, we could have said $100, whatever. We're just setting up the equation, the calculations. And then also we were able to check to see if it was reasonable. If I just take 0.098 times this, that's not enough. That must just be the tax. I also have to add the other thing. So then we put it there and they say, okay, this is my made up price. That's really where the letter goes. That's where it feels appropriate to just substitute back in the letter. But I don't know. For me, it works well. If it doesn't work for you, that's okay. Find something else that works for you. So I'll throw out all sorts of different strategies. But I find some of them that it might seem kind of kooky and stuff, and you say, well, why would we just do this? And some teachers, somebody might say that's not a good way to do it, but it works for a number of students. So if it works for you, you could use it. It worked for me. That's how I got through. I still do it. So far, so good. Anything else you want to see?
When we were talking earlier, can you explain what that symbol is
Oh.
and what it means?
Absolute value.
Sure. Let's go. Let's just get some screen area because we'll just talk in general terms. So the question was, it's still got a lot of stuff underneath there. Clear, yeah, it's good up there. So if I've got these bars, which are called absolute value, what do they mean? Right, the value, what do you mean by can't have a negative? Does that mean I can't do this?
Yeah, you can do that.
I can do that, but the answer
It's gonna change.
has to be positive. That's really what it does. It changes it to a positive answer.
So the brackets mean that it always has to be a positive number.
Yes, it will always, it's taking the value of the number, the absolute value, the magnitude, the size of the number, without regard to whether it's positive or negative. That's really what it's doing.
Because the question had the -7 it was n, but you'd say x equals -7. And so it just said the answer was 7.
Right.
But I didn't know how they came up with just, because they put it, where you have x, they had an n.
Okay, so let's...
So you could just, I was just saying, you could do x if you wanted,
Sure.
equals -7. So they meant n equals -7, but I didn't understand why they just said 7 when it was a -7. So I didn't understand that those brackets meant that it had to be
What's the
positive.
absolute value of -7 is 7.
Yeah, see, the thing is this actually has no solution if they had this thing. Well, maybe take a
No,
look
I meant
at
like
it.
n equals -7.
Oh, okay.
So, but they had the brackets were,
They did this,
uh-huh,
because this is not true. You can't have an absolute value, like you said, you can't have an absolute value equal to -7, because it can't happen, because those bars are going to make it positive. But you can say n is equal to -7, and so what that means is -7 goes in here. These bars, the absolute value bars, make it positive.
okay, so
It's
then
just sort of a-
7.
Yeah, it's mathematical magic. It just does it, you know. It's just, sometimes in math we do that. We just have something, and we would like something to happen, so we just say it happens. When I put these bars, that means take the positive value.
So the number n doesn't mean it's 1 and doesn't work in there? No?
Not in this one, because here they're defining what n is. N is a variable, and they're saying, but n is -7. So I put it in here. When I put it into the absolute value, it's going to make it positive. So now it's not, n itself is still -7, but the result of this function of putting it into the absolute value, the result is +7. And again, where it's used is to think about distance. So whether I drive forward with my car or whether I drive backwards or whether I drive to the east or the west of a mile marker, I'm still covering distance, right? So it's just, it's this concept of distance is never really negative. If I'm traveling, I'm traveling. Now, sometimes you want to have negative and positives. I went this far and this far. In reference to a particular item, I might be back there. So sometimes we do use negatives to measure travel distance, and because we're measuring distance from an object. But if we want to keep track of how far did we go, it didn't matter that we went 50 miles that way and 50 miles back. That's not 0 miles. That was 100 miles. So we have this idea whenever I'm traveling, it's always positive miles, whether I'm going in a positive direction or a negative direction. I keep track of how far I went, how many steps I took, how many miles. Okay, so in this case, here's -7, here's +7. Their distance is both 7. The distance from 0 is going to both be 7. That's the concept of absolute value. So that's why it's always going to be positive. And it's just put the bars and all of a sudden it becomes positive. Positives stay positive, negatives become positive. Does that help?
Mm-hmm.
Okay.
Yeah, I just needed
Yeah.
to know.
And the thing is, some of us, as we're looking, how does it happen? Don't ask that question. That's not a good question. It just happens because we say it does. That's not good enough, but it is. A lot of things in math is just somebody invented it, like imaginary numbers. Let's just make some imaginary numbers. And it's actually the thing that's weird about a lot of math. People just did that. They invented this letter I. It's an imaginary number.
Okay.
And you'll do this maybe when you get to 120. I don't think we deal with it in this class at all. But it's an imaginary number, and it's a way to get, the thing is in electronics, like in the phones you have, the microchips, imaginary numbers actually help them map those what do they call them? The microchips, the circuits, the micro circuits that go on there are actually using imaginary space. But if you didn't use it, they wouldn't work. It works. I don't know the details because I'm not an electrical engineer, but electrical engineers will use imaginary numbers that somebody just invented because they could, and they were just playing around someday, and let's be fun. Let's make some imaginary numbers. And it turns out that they actually solve a problem, and your little cell phones, or your cell phones that are basically like, have the power of a room full of computers 40 years ago, are all possible because of something that's imaginary and something that was invented in math that really didn't do anything. So that's kind of the cool part of math. You can develop things, and maybe if you go further on, maybe you'll be the person that says, when I write these 2 bars, it means this, and it just is because I say so. I haven't got that power yet, but we'll see, maybe someday. Okay. Everything good? Okay. So we got extra time. You're welcome to hang out, work through a few problems. I'm going to cut the live stream, or if somebody has some questions from there, it doesn't seem like it. But I'd be happy to work with you on any of the homeworks. Hang out if you'd like, or head out if you like. It's up to you.
Yeah, I have a couple that.
Good.
Maybe you could explain.
You got it.